The United Nations defines sustainability as meeting the needs of the present without compromising the ability of future generations to meet their own needs. Our city has a population of 2 million people in an area of 275 square miles. Our goal was to create a model of the city which shows that sustainability can be implemented, even in urban areas, to help protect us and our planet in the wake of COVID-19.
A major city like ours is comprised of a core downtown area, an industrial sector, a housing sector, transportation, green spaces, and resource access. We started our project with NASA-based research and then followed with research about other types of sustainability. We then created the basic layout of our city and implemented sustainable measures throughout it to get a comprehensive model. Our concentric coastal city model is shown here, with a large central business district, commercial centers, and housing districts surrounded by greenbelts to create smaller communities for disease mitigation. Highways and metro lines connect the regions to our city's port and tourism. Our design was based on NASA data like the Landsat datasets, which provide us with the ability to monitor urban change and to forecast future patterns in urban areas, as well as data from the EO dashboard datasets, which shows the data from before, during, and after the COVID-19 outbreak.
Our city will draw power from a multitude of clean, renewable sources. One source would be turbines inside water mains. The system safely harnesses energy that would otherwise be wasted. We will also use transparent solar panels as windows, which would take advantage of acres of available window space on office buildings and skyscrapers. Offshore wind will also be a critical part of the city's power supply. Offshore wind turbines could be significantly larger than their land-based counterparts, with large turbines capable of generating 8 megawatts each. The tidal current turbine works much like a wind turbine, but draws energy from tidal cycles, which allows it to operate continuously.
Decreased mobility and consequent decrease in carbon emissions in the wake of COVID-19 gives us an opportunity to change transportation to more sustainable methods. Our goals were to reduce carbon emissions, increase efficiency, and improve equity. For on-road travel, we encouraged ride-sharing, incentivized electric vehicles through tax write-offs, and established efficient electric bus systems with increased hygiene measures. The city is pedestrian-friendly as sectors are car-free, with a bike share program and extensive bike and pedestrian walkways. An underground electric rail system transports people from sector to sector. The concentric model of the city minimizes the need for transport, controlling both traffic and the spread of disease.
A city with our population would normally output 4.93 million tons of carbon dioxide. Carpool lanes and public transport, as well as other methods we used, such as city design, tax write-offs, and bike programs, allow our city to produce just 1.7 million tons of carbon. This is a major accomplishment.
When it comes to buildings, data from NASA's OCO2 satellite was used to create this graph of CO2 emissions per capita with respect to a city's population density. And as you can see, a higher population density is correlated with lower CO2 emissions per capita. So one step we can take towards making a city sustainable is to have more people living in tall buildings. And the next step is to make those buildings sustainable as well. Now let's take a look at the buildings of the future. Our buildings will be made of cross-laminated timber, which will reduce construction emissions over 30%. Windows will contain minerals called perovskites, which allow the interior of the building to cool down and prevent overheating. Green technologies will be implemented throughout the building structure. Gardens on the roof will include solar panels and wind turbines to counter the urban heat island effect and help the building produce its own energy. Sculptural gardens between floors will enable vertical farming and provide recreational space to the building's residents. Hydroponic underground farms will make use of LED lights as well as gray water from sinks and showers. In the age of COVID-19, a so-called bubble in which residents can live, work, and have access to food and outdoor space is necessary and what these types of buildings seek to create.
In order to incorporate as much green space as possible, we designed the city with a park wrapped around its border along tree-lined streets, pocket parks, and various garden techniques. Green spaces benefit both the humans living there and the surrounding environment, including lowering the average land temperature and reducing the risk of psychiatric disorders.
Throughout this project, we have all gained knowledge and opportunities we never thought possible. This internship has shown me the countless opportunities there are in the science field that fit my skill sets for the future.
I learned just how intertwined Earth, space, and environmental science really are.
Through this internship, I have learned much about different STEM career pathways, as well as how to effectively work on a virtual team.
I learned a lot about how hard building a city is, and I now have a newfound respect for city planners, especially those in more crowded urban areas.
I was able to explore a new topic of interest that I hope to learn more about in the future.
This experience has helped me learn about how many STEM topics are involved in everyday things like urban planning.